Hello everyone, in this video let's discuss about SR latch construction using NAND gate. So here we will be using NAND gate to construct SR latch. In next video let's discuss how to construct the SR latch using NOR gate. So NAND gate means it is the combination of AND gate and NOT gate. So what NOT gate will do? NOT gate will complement the bits. Complement. So it will complement the given input bits. That is, if 0 is given as input, it will complement it to 1. If 1 is given as input, it will complement it to 0. So now let's write the truth table for AND gate. First let's write for AND gate, next let's write for NAND gate. So if you write the truth table for AND gate, I will be considering A and B are my inputs and Y as my output. Now I am writing for AND gate. Since I am having two inputs, my possible combination are 0, 0, 0, 1, 1, 0 and 1, 1. What AND gate tells? AND gate tells when both my inputs are high, then only my output will be high. That is, when both the inputs will be equal to 1, the output will be equal to 1. And in all other cases, it will be equal to 0. But in NAND gate, what NOT gate will do, which is in front of AND gate, it will complement. That is, it will convert 0 to 1 and 1 to 0. So this is the NAND gate. This is the outputs of NAND gate. So now let's use the NAND gate to draw the SR latch. One NAND gate and this is the second NAND gate. My output will be Q and Q bar. That is, in latches also and in flip-flop also, the output will be complement to each other. That is, if 0 is here, here it must be 1. If here it is 1, here it must be 0. That is, both the outputs must be complement to each other. They should not be same. Now, what we will be doing is, we will be giving the output of one NAND gate as input to another and output of another to input as another. Like that we will be going. This is S, this is R. Now let's write the SR latch table. So S and R will be my inputs and my outputs will be Q and Q bar here. Like this. So since I am having two inputs, what are the possible combinations? 0, 0, 0, 1, 1, 0 and 1, 1. Now let's take this condition, that is 0 and 1. When S value is equal to 0 and R value is equal to 1. If you see the NAND gate truth table, when there is at least 1 0 in my inputs, at least 1 0 in my input, my output will be 1. If you see here at least 1 0 is there, output is 1. At least 1 0 is there, output is 1. At least 1 0 is there, output is 1. Here no zeros are there, so output is 0. So you can conclude that at least 1 0 in input side gives 1 as output. So if you see here, 0 is there, 1 is there. When 0 is one of my input, it will give 1 as my output. So 0, if 0 is my input, it will be giving 1 as the output. Now this output will be given as an input to this NAND gate. 1 and 1. When both the inputs are 1, my output will be 0. Here if you see, Q value is 1 and Q bar value is 0. Both the outputs are complement to each other. Now let's take this condition, 1 and 0. S value is 1 and R value is 0. Same condition apply. When one of the input is 0, my output will be equal to 1. So you can write 1 here because of this 0 only, output is 1. So you must write in front of that. This output will be given as input here, 1 and 1. Both inputs are 1, my output will be equal to 0. Here Q value is 0 and Q bar value is 1. Both are complement to each other. Now let's take this condition, 0 and 0. When both S and R are equal to 0, at least 1 0 is there, output will be 1. You can write here or you can write here. Now this 1 will be given as input here, 1 and 0. When at least 1 0 is there, my output will be equal to 1. So 1. Both outputs are equal to 1. This is not valid in SR latch or SR flip flop also, because the output must be complement to each other, they cannot be same. So you can write here not valid. This condition is not valid. Now let's go to the last condition, that is both my inputs are equal to 1. When both my inputs are equal to 1, my output will be 0. You can write 0 here, or here also you can write. Now this output will be acting as an input to this NAND gate, 0 and 1. When at least 1 0 is there as an input, you can write the output as 1 according to this condition. So the outputs are complement to each other, 0 and 1. Q value is 0 and Q bar value is 1. This is already in the memory. So you can write in memory. So this completes the SR latch using NAND gate. So hope you understood the concept. If you have any doubt regarding this topic, please do comment below. If you liked the video, please subscribe and support us. Thank you.